right, so on the first and second one, you're solving each system by graphing. Those are both in slope-intercept form, so easy to graph. The top equation, the y-intercept is at +2, and the slope is +5/3. So you have a rise of 5, a run of 3. If you go up 5, you're going to be off the graph. That's okay. We can still go down 5. But to be positive, would I go left 3 or right 3? Left. So on the test, probably having a ruler would be helpful. All right, and then the other equation, the y-intercept's at -4, and the slope is -1/3. So if I go up 1, do I go left 3 or right 3 to be negative? Left. And right there we can see what our answer is. Now on the test, these graphing ones are not multiple choice. You cannot just graph it, okay? You have to tell me what the solution is. So what would I say is the solution? -3, -3. All right, so that's not going to be a multiple choice problem. You have to tell me what your answer is. Don't just show me the graph. Any questions on that? And then y'all know the answer to number 2 is 1, -3. You can do that one on your own. On the back side, 2 more graphs, but these are not in slope-intercept form, okay? So you can either put them in slope-intercept form, or you can find the x and the y-intercept. It's up to you. I'm going to just put them in slope-intercept form, okay? So remember, that's y equals mx plus b. So you need to isolate the y, subtract x from both sides. -4y equals -x minus 8. Divide each term by -4. And y equals, here I've got a negative divided by a negative, so that makes a positive fraction, which would be 1/4 x. And -8 divided by -4 is +2. So my y-intercept is 2. My slope is +1/4, so I have a rise of 1, and it's positive, so I go to the right 4 times. Or if I go down 1, I go to the left 4 times. Okay, my other equation. Solve for y, so I'll subtract 5x from both sides. And I have -4y equals -5x plus 8. Excuse me. Divide each term by -4. And y equals negative divided by negative is a positive. So your slope, don't change that to a decimal, because you want to be able to easily see your rise and your run. And then +8 divided by -4 is -2. So my y-intercept's -2. My slope is +5/4. So a rise of 5 and a run of 4, and it's positive, so I'll go to the right 4. So my answer is 4, 3. If you put 3, 4, that would be incorrect. That's a different location. And the answer to number 4 is 2, -2. Of course, you're going to graph that one on your own. Any questions on those? Okay, 5, 6, 7, 8, it says solve using elimination. On number 5, the y's eliminate automatically, so we don't even have to do any multiplication. So combine your x's, you get 6x equals 6. Divide each term by 6, and x equals 1. Am I finished at that point? Nope, I gotta find the y. So you know you're gonna substitute that back into either original equation. It doesn't matter which one. I'll just choose the top one. And wherever you see an x, you put a 1. So it's -2 plus 3y equals 7. Add 2 to both sides, and 3y equals 9. So if you divide each term by 3, 9 divided by 3 is 3. So that's going to be an ordered pair. X comma y is 1 comma 3. The answer to number 6 is 1 comma 4. Let's look at 7. Do your x's eliminate automatically? No. Do your y's eliminate automatically? No. If we eliminate the x's or the y's, is either one of them going to be where we just have to multiply one equation by some number? Which one? Okay. And if we eliminate what? The x. So if we eliminate the y's, we're going to have to multiply both equations, right? So you can do that, but it's going to be less work if you eliminate the x's, because you would only have to multiply the bottom equation by what? Negative 3. And that would turn that into a positive 6x, which will cancel with this negative 6x, right? So the top equation is not changing. The bottom equation, you get 6x minus 18y equals negative 36. So this cancels. 4y minus 18y is negative 14y. And negative 20 and negative 36 make negative 56. Divide each term by negative 14. And I don't have a calculator. Is that positive 4? Anybody with a calculator? Yes? Okay. So y equals 4. Substitute that into either original equation. I'm going to go with the bottom one. Where I see a y, I'll put in 4. So negative 2x plus 24 equals 12. Subtract 24 from both sides. And x equals 6. So 6 comma 4 is your answer. Everybody good with that one? So I'm not going to work number 8 out, but on number 8, if I choose the x's or the y's, either one of those, would it just be where I only had to multiply one equation? No. So if I wanted to eliminate my x's, what's the least common multiple of 2 and 9? 18, right? So I'd multiply the top equation by 9, the bottom by 2, but one of them is going to have to be negative because they're both positive. How about if I eliminate my y's? 24. Okay, so I'd multiply the top equation by 4, the bottom equation by 3, and one of them's got to be negative. So I would probably eliminate my x's, and I would do the bottom by negative. But I could do negative 9 and positive 2, or positive 9, negative 2. I'm not going to work that out. And you know the answer to that one I already gave you is negative 4 comma 4. Everybody cool with elimination? Nine through 12, you had to use substitution. So in number 9, if your y's are already isolated, super easy to use substitution. Remember, you're going to substitute what the y's are equal to and set those terms equal to each other, or those expressions equal to each other. So I would set x minus 3 equal to negative 2x plus 21. So notice now you only have x's in your equation, so you can solve for x. So there are several things we could do here. I personally would choose to add 2x to both sides first. I like to get my x's together and I like to make them positive. So x plus 2x is 3x. Then I would add 3 to both sides. Divide each term by 3, and x equals 8. Of course, you have to also solve for y, so take that and substitute it back into either original equation. I choose the top one. Wherever I see an x, I'll put an 8. So x equals 8, y equals 5. That is 8, 5. On number 10, your top equation already has the y isolated, but the bottom one doesn't, so you're going to need to isolate the y on the bottom equation first. 11 and 12, neither has an isolated variable, so you're going to have to isolate on both. So I'll do 11 with you, and since this x has a coefficient of 1, I would probably isolate my x's first, because that's just going to be one less thing that I have to worry about. So if I isolate my x's, then I would add 3y to both sides. That's x equals 3y minus 15. And in the other equation, I have to isolate the same variable. So I'll isolate my x there. And if you get a fraction, just leave it as a fraction. Don't change it to a decimal, because we know how to clear the fraction. Okay? So I'm going to substitute what my x's are equal to and set those equal to each other. And I know I'm going kind of fast, but it's a C day and we don't have a lot of time, so if I want to clear my fractions, which I do, I will multiply every term by what? 3, because it's the least common denominator. So 3 times 3y is 9y. 3 times negative 15 is negative 45, equals, these 3's cancel. Now notice a lot of you will cancel the 3 and still multiply the 3 and the 4 together. Don't do that. If it cancels, you don't multiply. So you're just left with 4y there minus 15. So if I get my y's together, I would subtract 4y from both sides. I'm going to have to continue on paper. So I have 5y minus 45 equals negative 15. Add 45 to both sides. So 5y equals 30. So y equals 6. Then I'll take that and substitute it into either original equation. Wherever I see a y, I'll put in 6. So I have x minus 18 equals negative 15. Add 18 to both sides. And x equals 3. So 3, 6 is your answer. So on the test, if that was a multiple choice and I said solve using substitution, but you thought elimination would be easier, are you going to get the same answer if you use elimination? Yeah. So if you mess up on substitution all the time, use elimination. Okay? But if it was not a multiple choice and I said specifically to use substitution and I wanted to see your steps, then you would need to use substitution. But it's multiple choice, so yes. No. Everybody cool with that one? Okay, I'm not going to do 13 for you, but I am going to help you set it up. On the test, of course, you have to set it up and solve it. But Perry and Eugene are selling flower bulbs for a school fundraiser. Customers can buy packages of tulip bulbs and packages of crocus bulbs. Perry sold 7 packages of tulip bulbs and 4 packages of crocus bulbs for a total of $142. Eugene sold 14 packages of tulip bulbs and 12 packages of crocus bulbs for a total of $356. Find the costs each of 1 package of tulip bulbs and 1 package of crocus bulbs. So we got to figure out how much each package costs, right? So we need variables for what? Packages of tulip bulbs, the cost, and we need a variable for how much a package of crocus bulbs costs, right? So I'm going to let X equal cost of 1 package of tulip bulbs, and I'll let Y equal the cost of 1 package of crocus bulbs. So problems like this, I notice I've got 2 totals. I got a total for how much Perry sold, and I have a total for how much Eugene sold, right? So one of my equations is going to be about Perry, and the other equation is going to be about Eugene. How many tulips and crocuses Perry sold, and how many tulips and crocus is, I think that's the plural of crocus, Eugene sold. So anybody have an idea of what Perry's equation would be?
17 plus 4c equals 132.
All right, perfect, but I use X and Y, so I'll say 7X, because he sold 7 packages of tulip bulbs, plus 4Y equals a total of 142. So Eugene would be
14x plus 12y plus 356.
very good. And does it tell you what method you have to use to solve it? Nope, so whatever one you want, okay? 14 and 15. I'll do one of those. I'm gonna have to use a separate sheet of paper for I'll show. I'll do number 14. All right, so I'm gonna label these equation A, B, and C. Are there 2 equations that I could pair together and something would eliminate automatically?
Yes.
A and C. Okay, so I will start with A and C. Cancel my B's. Negative A and 2A make positive 1A or just A. Positive C and positive C make positive 2C equals negative 8. Since I have 2 variables there, I'm going to call that equation D, and I'll come back to it. Okay? Remember, you have to use all equations at least once. So I have not used equation B yet. And so I'll either have to use A or C twice, it doesn't matter which one I choose, but whichever one I choose, since I canceled the B's in the first step, I have to cancel the B's in the second step, okay? So I would probably choose to pair it with equation C, only because your B term, I would have 1 positive and 1 negative. That would just be one less thing to worry about. So even if something canceled automatically here, unless it's the B's, we don't want it to cancel, okay? Because it won't pair up with equation D. It doesn't, but that happened on one of our homework problems. So if I want my B's to cancel, I'm going to have to multiply the top equation by 3. So I get 12A plus 6B minus 15C equals, what's 18 times 3, y'all? 54, thank you. Bottom equation, I'm not multiplying anything. 6b minus 6b cancels. 12a and 2a make 14a. Negative 15c plus c is negative 14c. Equals 56. And I'll call this equation E. Now what? Bless you. Combine D and E together. And if you notice, both equations have the same variable. We did that on purpose. If we would have not canceled the same variable in step 1 and 2, then we would not have the same variables here. They wouldn't match up and it wouldn't do us any good. Okay, that's why it's important that you cancel the same things. So, I would probably multiply the top equation by 7 and to get the c's to cancel. Okay? So I have 7a plus 14c equals negative 56. Bottom equation, I won't have to multiply by anything this time. So my c's cancel, and I'm left with 21a equals 0. Is that okay? Yep. Divide each term by 21, and a equals 0. Now, when I only know one variable, can I plug it back into A, B, or C? No, I can, but it's not going to do me any good because I'm still going to have two unknowns, right? So where should I substitute A equals 0 into? D or E? And I'm going to go with D just because the numbers are smaller. Wherever I see an A, I'll put in a 0. And I can solve for C. So now that I know two of the three variables, now I can substitute those back into either A, B, or C. And I'm going to substitute it into C. But it does not matter which one. I know A is 0. I don't know B. And I know C is negative 4. So plus some negative 4 would just be minus 4. So that's 0 minus 6B minus 4 equals 2. Oops, sorry. Add 4 to both sides. Negative 6B equals 6. And so B is going to equal to positive 1. So remember, if you were to graph this would be on a 3-dimensional graph, and your ordered triple is a location on that graph, right? So the order in which you put your answer is important. It's got to be in alphabetical order. So A, comma, B, comma, C. So this would be 0, comma, 1, comma, negative 4. That's an ordered triple. What? Did I make a mistake? It's what? Oh, thank you. Yes, B is negative 1. That is important. Thank you. 0, comma, negative 1, comma, negative 4. (16 and 17), those are systems of inequalities. Remember, when we did the notes on systems, all of our systems of inequalities were word problems. And I told you on the test, they weren't going to be word problems, just the graphing, okay? So, they're shading. And on the test, they only shade the overlapping region. That's the only part that they show on the multiple choice, okay? And I can't remember if I put multiple choice on those or not. They may not be. You may have to just not be multiple choice, if that made sense. Okay, so on the top one, my y-intercept's positive 2. My slope is negative 1 over 1. So I have a rise of 1, a run of 1, and it's negative, so I'd go to the left. Up 1, left 1, up 1, left 1. or down one, right one. And it's an or equal to, so that means every ordered pair on the line is a solution, so we make it solid. Students are still struggling with where to shade. Greater than or equal to means shade above, okay? Well, what's above? I don't understand, especially when the lines are really steep. Students struggle with that. So if you're not sure, look up here. I'm going to call this region A, and I will call this region B. Where do you think you shade? Region A or region B? Where? Nobody knows. B. Thank you. That is true. If I wasn't sure, let's say 0, 0 is an easy ordered pair to plug in, right? So if x is 0, y is 0. If I did 0 is greater than or equal to 0 plus 2, that means 0 is greater than or equal to 2. Is that a true statement? No. So I picked an ordered pair that falls in the region that I didn't think I was supposed to shade, and since it made a false statement, that means it's not a solution, so that's not the region I would shade. It definitely is this region that you told me it was going to be. So y'all were correct. But greater than is above, less than is below. Greater than or equal to is above, less than or equal to is below. Tyler, you have a question? Nope, stretching. All right, on the other one, y is less than 3x minus 2. My y-intercept's at negative 2. My slope's positive 3 over 1. So rise of 3, run of 1, and it's positive, so I go to the right. Now look, this is less than, not less than or equal to. And I told y'all when we did the lesson that that would be a dash line, but we never actually had one like that. But if there's no or equal to part, bless you, it's a dashed line. That means it's like a boundary, but any ordered pairs that fall on the dash line are not actually solutions. It's just the boundary line, okay? So problems like this where the line is very steep, this one does get kids on what's above and below, okay? So I would probably definitely pick an ordered pair because you have, it's kind of like more on this one, the right side and the left side instead of above or below. So if you get confused, pick an ordered pair. I'll pick 0, 0 again because it's really easy to substitute in. So when y is 0 and x is 0, that would be 0 is less than 3 times 0, 0 minus 2. Is 0 less than negative 2? No, that's a false statement. So this ordered pair lies in the region that does not contain solutions. So we know then it must be the other region that we shade. So your actual answer is where they overlap. So like if you have two equations and your answer is the ordered pair where they intersect, and you have to give me that, when it's inequalities, your answer literally is the graph because you can't list all those solutions in that region. Okay? Any questions about that? So be really careful on your graph because I think that I did not make this multiple choice. Use a ruler, make it precise. Don't just willy-nilly throw a line on there, okay? Because if it's not precise and I can't tell what your y-intercept is, what your slope is, and where you shaded, then you're not going to get points for it. And it's like 7-something points each. Yes. Because, did I do it wrong? Did I make an error? When I plugged in 0, 0, substituted that in to see if it made a statement. So I got 0 is less than 0 minus 2. Is 0 less than negative 2? No. So 0, 0 is not a solution, right? So that means that fell in this region here. And if it did not make a true statement, then that's not the region where my solutions are. The solutions would be in this region. If it made a true statement, that's where I would have shaded. Does that make sense? Okay. I'm running out of time. On the bottom, that's just review of equations. I put 2 or 3 on the test. Pick one for me to go over. Do you want me to do the fraction ones? Yeah? Okay, fraction 1. I'll do number 20. On number 20, what is my least common multiple of 6 and 3? 6. So I'm going to multiply each term by 6 to clear the fractions. Now in the first fraction, the 6's cancel, right? And I'm left with negative 23 equals, this term we don't have a fraction, so 6 times negative 2a is negative 12a. 6 times positive 5/3, the 6 and the 3 don't cancel, but we can reduce because 3 goes into 3 and 3 goes into 6 evenly, right? So we could say 3 goes into 3 once, 3 goes into 6 twice. So that 2, I'll just multiply by the numerator. 2 times 5 is 10. And there would be a 1 in the denominator. We don't have to put 1 if that's what your denominator is, right? Over here, again, we can reduce the 6 and the 3. 3 goes into 3 once. 3 goes into 6 twice. So 2 times 5a, and that was, is that minus? So that's negative 10a. And I have like terms on the right side, so I'm going to combine those first. Negative 12a and negative 10a make negative 22a plus 10. Subtract 10 from both sides. I get negative 33 equals negative 22a. And when I divide by negative 22, a negative divided by negative is a positive, and I'm going to leave it as a fraction because your answer will be as a fraction if it's multiple choice, which it would be. And 33 over 22 reduces to what? Close. 3/2. So 11 goes into 33 3 times, 11 goes into 22 2 times. All right? And that concludes the review.